Okay, got everything all cleaned up. So main case is over here. Ugh. So you can see the wear. The bearing area better now. The needle bearing's got a lot of wear in the rollers. When I was cleaning it up, the rollers are going at an angle pretty good, which means they're loose. You can also see there's a pretty good gap between the rollers right here, which means it's getting loose. Screwdriver. So if you go like this, you can see the gap in between the rollers. When you stack them all up, total gap tells you where we're at. This one doesn't look too bad this way. Yeah. The gap doesn't look too bad, so I guess it's okay. Just looked like they had a lot of angle to the rollers like this when they're spinning, but oh well, they look alright. Okay, so I'm going to throw a bore gauge in here and measure this and see what condition this is in. So I'm not going to actually measure for size, I'm just going to see what it is. And this is obviously the wrong setup on there, so I can't do that right now. We set that all up, so that ain't going to happen. Alright, this here is really tight on the shaft for some reason. I stretched it out a little bit to make it so I can get the thing on and off. I never had one of these tight on the shaft before, so I'm assuming somebody probably crushed it to make it tight, because normally they just slide on and off. So I'm not sure what that's up about. It is what it is. Just look over the teeth. You got a nice wear pattern going on the tooth right there, so that looks good. Not too bad. The snout here looks nice and clean and fresh, not all scarred up. The bearings, the rollers look like they're fairly new. So they're not even broken in yet all the way across, so that's pretty new. So we have to pop the clip and slide it over so I can true it. Excuse me. Alright, I'm going to get the tripod over here. Ah, hitting everything over here. Alright, so now we can work on it. You got to pull this clip off to get be able to get true it. Plus you got a heavy duty clip on it. Okay. These are mix and match in different years, parts. Pretty tight on the in play, but it has in play. That's all that matters. Done moving? Because only it won't come off the side I'm trying to get it off of. Alright, so now I can put an indicator in here and check that. Hopefully it'll clear. And I can put one over here so I can check to see how true this crank is. So we can do that. Alright. Get my shingus over here to work. Looks like we had 1/800 is what we were using last time. You always want to put your indicator off the edge of the table so you don't beat up the surface right here. It's kind of important. 600 to 120. I'll do the 40. Put the right parts on there. It should be for 1750 size wise. There's our checking standard. They don't make this brand anymore. Okay, appears to be correct because we can actually check the thing. Okay, now I got to zero this out. Way over here. So now it's just a matter of making it zero. Looks like we're just a little bit over. To where I can see it. Too far. Put it back a little bit. You don't want to waste too much time doing this because you're heating up the parts as you're doing it. They're getting worse, not better. Dumbass is doing it, that's why. Okay, see I got a zero right now. So we check it over here in multiple places here when we're doing this. Alright, the more I hold on this, it'll start growing. Heat will change that number by 1 to 2 thousandths. And we're working to tenths, so you can know how bad it gets. To be accurate, everything has to be at the same temperature. Whatever that temperature is, it all has to be the same temperature. Then you get accurate. Okay. Come over here and check our case. See what size we got, how round it is. Not bad. We're just about basically between 15 and 16 and a half. So one spot it was a 14 and a half. So you got a 1.5 to 2 thou or 2 tenths variable, which is close enough. I like it to be within a tenth, but yeah, whatever. It's good. It's under 3 tenths. 3 tenths is my limit. So we're good. So it's fairly big size too, so I have to measure all this to see what size this all is. But at least the case is round. Within tolerance. I'll probably give it a quick flash on it anyway. Square it up. Okay, so we got that handled. So now I gotta throw this thing in the kiln and see how far out true this is. I need to put a little bit of oil on the end here for the tapers. Okay. I'll take this over to the truing stand and see how true it is. He claimed it was a smooth running bike. Let's find out how smooth is. You never know until you check it. There you go. All right. far over. What the hell did I do last? Just been working on a late model bike last time. Not very true. Doesn't meet my standard anyway. So each one of these lines over here is 2/1000ths of an inch. That's what it works out to be in. Preferably, Harley says under one line, 2,000 is your limit. I like to be like half a line. So you can see how it's moving more than half a line. It's moving a couple lines. This one over here is about 3/4 of a line. I don't like it being that bad. That's almost a full line actually. 3/4 is kind of my limit. I don't like being up more than 3/4 of a line. Preferably I'm under 1/4 of a line or less, but half's kind of where I like to be at, under half. So this one needs a little work. Now let's see how far out this is. High spot is about 90 degrees out that way. About 90 degrees out in the same spot over here. So basically it's too wide right here. So it needs to be spread over here. Of course that'll spread it here, but you got to push it back after you're done. So you got a little bit of a twist in the wheel like this. So it just needs to be worked on a little bit. But the indicators are moving pretty evenly as they go back and forth, which means the crank is relatively straight. It's not twisted at the crank pin. Scissoring is what they call that. So they're pretty straight that way. It's just sitting out here is what the problem's at. All right, so at least now we know where we're at. So I know how smooth a smooth bike is now for the customer. Not very. 4/1000 out of true is not very true. Not very smooth. So that means he likes a rough running motor. So we don't have to worry about balancing too much. If you're out of true that far, balance is a waste of time because it shakes too much already. So now we're going to take it apart and see what the rod feels like, looks like. Let's see here. Okay, I always take the left wheel off because the right side is keyed, because there's an oil gouger over there. So it has a lot of sleeve retainer Loctite on threads, so I know S&S put this crank together originally. The nut's loose, but it's really, really tight, because the Loctite's still working hard. So you can either heat it up to 350 degrees and melt the Loctite, or just keep pulling it off. You can see the Loctite residue on there. You can also smell it. And if you look at the color, it's green. Red is red color, green is green color. You want to see what red looks like, you go over here. That's red. I don't think it had red Loctite on the screws, but it's got red on the screws right now. It has some kind of sealer on there. Well, the rollers fill out. Good. They're coming off anyway. Alright. So now it's a matter of popping the flywheels apart, which is probably going to be kind of hard to do. Unless they put their stuff together like I do, really, really tight. Take all the rollers off. Alright. Well, usually I just hit my big hammer right here in the face and it pops them, but from past experience I already know it ain't going to come loose doing it that way. Just a normal tool you use, so you just whack it flat right on the face there and it pops it. Not going to work on this. I like to use a manual method called a hydraulic press. I'm going to squeeze the flywheels and beat on them with a hammer. At some point it's going to come free. It's just a matter of how much effort it's going to be, how much force I got to use. All right. Okay, so you just put the flywheels over here like this. So you're going to put pressure right here, which should pop the Loctite over here. Get it to come off. That won't fit, so we're not going to use that. Use one of these over here. We'll put a little ton of pressure on it. You can see how just everything just kind of moves, but it doesn't really pop it any. So that's got about 2 tons of pressure, 1.5 tons on there right now. So we come over and get our body hammer, and we shock it a little bit. See if that freed it up. It probably didn't. Didn't put enough force to it yet. Nope, still tight. So that was just kind of a get friendly amount of torque. So now you put more pressure on it. So about 2.5 tons. And we shock it again. A little bit more force. It might have popped that time. Oh, appears to not be popped yet. Double check. It's popped. I thought it looked like it popped. And the reason I thought it popped was because the crank pin, instead of being like that, was looking like it was straight up and down. So even though it didn't want to come off, it came off. Yeah, we could say I'm destroying tapers on the flywheels. Yeah, well, oh well. So you get them apart. So you can see all the Loctite on the taper, and the Loctite there. And you can smell it if you had smell-o-vision. So we don't have smell-o-vision, but take my word for it. I can smell the Loctite. Okay. Looks like the wash area looks good. So that's a good one. Used to have a rag in my pocket. Oh, it's over there. Okay. There's my missing rag. Let's see. Looks like it's got the S&S style bearings in here. Wonderful. Yep. Okay. Because you've got the new style rods. So I know this crank isn't very old. It's probably only about 5 years old at most. Yep, new style bearings that fall apart everywhere. I hate them. Yep. See, I can't do anything with one hand, so half the bearings are on the floor now. I gotta go hunting for them. That's the problem when you hold the camera with one hand, you can't work. I don't know. Too bad. We'll find them later. He wanted to upgrade the better stuff anyway, so we'll upgrade the better parts. Which means we're not using these rollers anyway. These are basically new ones though. You bounce out the pan, go on the floor too over there. Alright. Here's one. And there's probably 4 or 5 to it down here. I only see 2. That's why I put this stuff in front here, so it bounces back. Yeah, I only see 2. Yeah, we'll count them later. Might be more missing. Alright. So it's a 2-hole crank pin, which is what S&S uses. It's an S&S pin. Tell that by the looks of it. It's got almost no miles on it. So, no doubt this crank has got hardly anything on it. You said it didn't have very many miles on it. Yep, that's true. It's just barely even got wear marks on it. Okay, I got to get this all off of here, so I got to. Easiest way to do that is pull the pinion shaft off. That's the easiest way to do this. Normally I don't take these apart because S&S puts their stuff together really, really good. I don't have to take it apart easily. But oh well. Alright, camera's going to go lay down on the bench for a minute. Just side view. Good Loctite. Alright. Appears that was on there pretty tight. What a shocker. Okay, now I gotta take this off. Back to tripod. Alright, this we're gonna use a press on it. We can actually press on it. Okay. Like that. Yeah, it'll be fine. Okay, so now we just put a little pressure on it. Switch hands. Okay, see I have this bucket of crap down here? That's for it to go boom into. Now right now, somebody's got too much wood in my way over here. The wood pile has grown. So, try to get the bucket back over there where it belongs. So you want to be able to blow it from here right into that bucket. Now it's going to come out of here like a shotgun. So I'm going to crank this thing up to high pressure. It'll pop probably about 8 to 10 tons. Oh, 6. It only went at 6 tons. Yeah, it didn't come all the way out either. So the key right now has got it held in. So that's how they come out of there, pretty tight. So I'm going to try to get it out. Got to get past the key, which is also loctite in. So the way you do that, you got to hit it with a hammer. What a shocker. More beating. Something just fell. And what I gotta do to get this out is I need to hold this straight and then beat on this right here, or press on it. Usually pressing doesn't work because it just overcomes my leverage for me holding it. So I can't hold back tons of pressure with my hands. You see all the sleeve retainer Loctite on there? See, I use sleeve retainer on the taper, but I use red Loctite on the nut so I can unscrew it easier. Sleeve retainer is just a little bit too much for everywhere on the whole bike. Okay, now I can get all this stuff here off. That wouldn't let me do it before. Take a look at this and make sure it's wearing nice and smooth and easy. I don't like how it's all discolored. It's like it got hot or something, but there's no reason for it to be hot. The bearings didn't show that. Okay, now we gotta get this out. This obviously is now off. So I got my bearing puller. I go on here. And see how much we can put pressure on this here. Alright, so I'm going to push on it on the hard way, which is the flat side, so it's got more force. If you push on a taper, you're just going to try to bend my tool. Okay, now if I put it between the blocks this way, the bolts will bend. If I put it this way here, you're going to try to bend these, which you're not going to do. So it gives me more pressure. Alright, now we're just going to put a little pressure on this, and it's going to wind up going boom right down in that bucket down there. Kind of like that. See, that's what you do with your old inner tubes. They come in real handy for stuff like this. Alright, so that popped off nice and cleanly. The key is missing. The key is not here either, so that means the key is down there. I don't see it. So somewhere in there should be a key. Guess I'm not seeing it anywhere. Okay. Come off just a little piece at a time. I got multiple impacts. It must have been lost from the previous job. I don't see no key. Appears the key went bye-bye someplace. There's a bearing. If we're missing one, we know where it is. Uneven surface work better for stopping bouncing. Could have the oil on in there too, just in case you need someplace to put it. Alright, so I don't see it. So the key went bye-bye. Don't know where it's at. I'll play back the video, maybe you can tell me where it's at. See if anybody saw it. All I know is I don't see it. So I have to buy a new key. I think that was defective, right? Okay, so that's how all that comes off. Let's see, this came from up there, I think. Yep, way up there. Right there. Okay, I'm not going to pull apart these other parts because I know S&S puts their stuff together really, really tight. They do it the same way I do, so I don't need to redo it. So it comes off cleanly. Okay, this will clean this up and measure it, and we'll check our bearings for over there. I'll clean these parts up too. Okay, next thing is our connecting rods. We want to see what kind of what's going on with these. They look pretty good. Now I'm going to check for size. I'm just going to check to see if they're straight. Straight and round. Alright. So you got 3 indicators here. So we measure it by moving the either this one or this one. I think it's this one here. Yeah, this one here is the one that does it. See, I move the dial up there. Okay, you want that to zero out. I think the light's hurting us here. Okay, so I like this being within 3/10 max movement, preferably within 1. Okay, 1/10 is one line. That'd be one of those lines right there. That's 1/10. 0 to 1 is 1 thou. So we have that much. So we're at 7. We go down to 6 under. 6 and 7 is 13/10. That's 1.3 thousandths. That's not very round. That's why the rod felt tight, even though you could slide it. And just in case you thought it was bad on 1/2 the rod, no, the whole thing's junk. Okay, so to hone that out, I'm going to be way down here to get it bigger, which means I'll be in oversized rollers. So, now from past experience, when I take these cranks apart, which I've showed you before, S&S can't seem to get their stuff within 1/2 thou about around anyway. Usually it's more like 8/10, and we're just a little bit above that at 13/10. Okay, what's this one at? This one's about the same size, and it's just as bad. No, not quite as bad. It's 1 thou out. And this one here is a little bit better. 3 to 5. It's only 8 out. Oop. You rotate it. When you rotate, I'm pushing this direction here, down. This is the rubbing block, this is the rubbing block, this is the one that counts. So you can see how it's not very round. Alright, so this is junk. That's why I took the motor apart. Well, I figured there was going to be something wrong with this rod set. There is. That doesn't surprise me one bit. Excuse me. Now I got to check the fitment on those. Let's get some parts over here. I need this piece right here. Figure out this, we need this. We gotta measure this, see what it is too. We'll get kind of a rough idea what kind of size and S&S did their stuff at. What they say they do and what they do is not the same thing. 2 mics spokes out, one for the crank pin and the main shaft, and one for the bearings. Let's do the crank pin first. This is 1 1/4 plus or minus half a thou usually. So there's 1 1/4. Turn the light back on, might help. Oh, damn. That's a full thou undersize. Jeez. That is a small crank pin. 11/10 under. Yep. That's way undersized. See, 0 is way over here. We're 1 full line. And if you go over here, we're not on the 0, we're at the 9, which means we're 1/10 under. This is a veneer scale over here. These are tenths of a thou when it lines up there. So that crank pin's 11/10 under. So that means you have to compensate when you measure everything. That's really small. The rollers over here. Now these are supposed to be 3/16, which is 187.5. Most of the time, modern day, this stuff is always a couple tenths under. Standard is 2/10 under these days for some reason. In case you think it's my mic, the other one has the same error, has the same issue. So, all right, see, it should be right in the middle, halfway between. It's not. It's only like it's like a quarter of the way up. So if you go over your veneer scale, you find the one that lines up, and you see it looks like it lines up with that one right there, which is number 3. So that's 3/10. It should be 5/10. So that's 2/10 under. So that seems to be the new standard for the last 12 years or so, 15 years now they've been doing it that way. Okay. And this one looks like it is the same, if not a little smaller. This one's slightly smaller, we're at 2/10. See, the number 2 lines up right there. And over here you see you're under the 7. So that's 3/10 undersize. I doubt if these are worn already. Grab another one. This one is 2/10 again. See, I can spin the roller right here. So there's tension on it, but not a lot. You can clamp this thing down any number you want. It just breaks things. You have to adjust the mic for the feel that you have. Everybody has a different feel they use. So I know 2 mics are set identical. This one's worn. It's probably down at 1. Yeah, it's at 2. It's at 2 still. Alright, so we seem to be between 2 and 3/10, which means we're 2 to 3/10 undersize. So if you take the 2 to 3/10 undersize, now a roller is on both sides of the crank pin, so you have to double your air. So you take those 2 numbers, we're between 2 and 3, we add them together, so that's going to be 4 or 6/10 undersize. We have to just say average and make it 5, we're okay. The crank pin was 11/10 under, so that means we add that into the mix. So 11 and 5 puts us at 16/10 under. If you look at that scale over there, if the scale was still accurate, which I haven't checked yet, we were at 17/10. So that rod had 0 clearance on the tight spot. There's no clearance. No, we weren't 17 under, excuse me. We were 7/10 under. So that means we had 1 thou clearance on the rod. Yeah, you have to have it set right. I didn't check it over there yet, because this is 17 under, not 7. That was 7 over there. So it's all about the numbers. So basically it looks like they're using about 1 thou clearance, and then they're way the hell out around. But that rod felt a lot tighter than 1 thou to me. Okay, so we got to do a little work on that, obviously. I'll probably be using 1 thou over bearings to fix the problem, which only gives me about 5/10 extra clearance to hone that out, maybe 7/10 to get that to round out. I should be able to do that. Okay, now we can go over to this one. There's the key right there. Now we do all the same stuff again, number-wise. These are same basic size, 1.25 inches. Okay, this one's not 1 thou under, but it's about 5/10 under. These are rarely undersized. They're usually on size. So you see it's about halfway around there. You have to spin around over here to see where the 10th mark is at. So I like leaving it on the part when I check it, so I know I haven't moved it any. Looks like we're around 6/10 there. I think it's the number it's on, the angle I'm looking at it. Let's get over where I can see it better. It's between 5 and 6. About equal here on both lines. So we'll go with the bigger of the two, 6. We probably should check to see if it's around. You should check it more in one spot. 5 right there. Go over here and check this one. This is bigger on this side. That's 8. No, it's 7. Excuse me, 7/10. So we got 1/10 and a half, 2/10 of taper in this crank in a shaft. 7/10. Typical S&S quality, not very good. Jim's is usually within 1/10. I'm not sure who makes the better material though. Jim's has issues with their materials. They're cheap. S&S is probably might be better material. I don't know. I don't hear about S&S pins breaking. I do hear about Jim's pins breaking though. Okay, now we got to measure our big roller. These are 1/4 inch rollers, so they should be 250. And right off the bat, they're not at 0, they're undersized again. What a shocker. And looks like we're right about 7 8/10. Look at the scale. So this one's going to come up pretty loose. Looks like 7. So we're 3/10 under. So that's 6 plus 5 is 11/10 under. And the bearing race over there was 15, I think, wasn't it? I think it's 15. Yeah, 15 to 17. So we'll call it 16 average. So this is 16 over, and all those other dimensions put us at 11. What was it? It was 6 and 5. Yeah, 11 under. No, 6. We'll call it thou under, because when it was 5 to 6/10 on the shaft, it was 7 on the big side, so we got to take another 10. So we'll call that about 9 average tenths under, plus 15, or I mean plus 16 over. Means you got a lot more than 9/10 clearance plus or minus a couple. It's pretty loose on the pinion side. So that allows for a lot of shaking in there, which is good for race bike, not the best for street bikes. So that's a race bike clearance on that side. So if the Timken's nice and loose, that's a good setup for a higher RPMer. long stroke motor like this is, but that's not normal what you put them in at. So we might go a bit tighter on that bearing. We'll see. We'll see what the customer wants me to do. I'll go give him a call here a little bit. So, but anyway, that's about how these all go together. So on the teardown, you got to do a little inspecting as you're going. You look at it as you take it apart, you look at things, and you see what's going on. That's how you find out what's really wrong with these motors. Now, the next problem I got is the piston in here did not want to come out earlier. It's really, really sticky, like there's dirt or sand inside here, or beads or something. And it hasn't cleaned out yet. It's still tight in there. It doesn't like to come out. See, it's tight. It should just drop right in and come right back out. So there's something wrong with that. See, now I got it stuck in here again. And see, it comes out. It goes in, but won't come out. Have to tap it out to get it out. So this plunger is tight inside of this hole. Now, I didn't mic this yet to see if this is out around. But there's something wrong with it. Here's my other mic. Something is not right. It's rough, I can feel it, but it's round. So I'm going to have to polish on this a little bit and polish inside that bore and the pump too. More problems. Alright, that's it for now.